Today we're going to talk about chapter 2 of the new Turing omnibus, and this chapter is about finite automata. Finite automata is quite an easy topic. Again, it's like it's really quite simple. It actually took me a while to understand, but I think I was kind of overcomplicating what it actually is. So finite automata. Finite automata, it's in the middle of the Chomsky hierarchy of languages. And I don't really know what that means, but I think what it kind of means is it's a really simple form of communication. And it's how basic computers work, and I think it's how Turing's first machine works. And it works by this, like, it's really quite simple. So there's no memory in this. This type of automata, it doesn't have any memory. So all it is a machine which takes in an input, changes the input through, whatever the machine does, and produces an output. And then from the output, it then moves. So there's this thing called so when you're talking about these finite automatas, you can use a thing called a state transition diagram. And what this transition diagram does, as shown here, basically it shows one state, and then if you input something, the change in state of it, like in the machine. And so I was watching a computer file video just then, just to refresh my knowledge. And what they always talk about were vending machines or parking ticket machines, as an example of finite automata. And what they were talking about was, if say it costs 25p to get your parking ticket, there are multiple routes of getting there. So there are multiple state transition diagrams. Sorry. For example, you could have 5p, 10p, and then 10p. You could have 10p, 5p, 5p, 5p. So there are multiple ways of getting to 25p, but like the machine doesn't have memory. It just takes an input and then it responds to that input, and then from the new output, it then takes in another input to change the output until it reaches its end goal. And in computers, in like coding, as a more sort of practical example, computer scientists, they use this finite automata for variables. So I think in different languages, the variables only take letters as their first value, as their first character. If you have a number as your first character, it doesn't take in as a variable. So I suppose what a computer's doing is it's iterating through the variable to see what it is as a variable, and then the final thing indicating like the end of the state is a semicolon in many languages. I mean, for Python, I don't think they do that, but I think for C++ they do that. I mean, I'm not that familiar, but yeah. Nice. Okay, moving on. Systems of logic.